With Chapter 6, we now get to the fundamental concepts that will thread through the remainder of the course, and perhaps the most useful statistical tools for a business manager. We will focus on continuous probability distributions, with emphasis on the uniform and the normal. While the text covers exponential distributions, we will only give it a mention in this course. The first of these 4 Chapter 6 lectures will focus on the uniform distribution. In Chapter 5, we introduce the difference between discrete and continuous variables. A continuous variable can assume any value in an interval. Given that, there are an infinite number of possible values in the interval, and as a result, the probability of any one value is 0. Instead, we will consider the probability of a variable assuming a value within an interval. As stated previously, we can represent a probability distribution with a formula and a graph. A key to our ability to determine a probability is the fact that the probability within an interval is equivalent to the area under the curve or the graph within that interval. The uniform continuous probability distribution is probably the simplest. Similar to the discrete uniform distribution, the probabilities are uniformly distributed across the range of potential values. The function is represented by this simple formula, where b is the largest value and a is the smallest possible value. For a uniform distribution, we can calculate the expected value, or the mean, as well as the variance, and then from the variance calculate the standard. For an example, let's consider a restaurant buffet. You can see the function for the variable x, where there is equal probability in any interval across the range of 5 to 15 ounces, where the variable x is the salad plate filling weight. You can see how we would calculate the mean and the variance. Any uniform continuous distribution can be represented with the graph of a rectangle, where f of x, the probability, is on the vertical or the y-axis. You will note an equal 1/10 probability for any 1 unit interval across the range from 5 to 15 ounces. Rule of probabilities. The sum of probabilities for all possible outcomes must equal 1. Looking at this example, then, we know that the total area under the graph is 1. To determine the probability of being in an interval, for example, of from 12 to 15 ounces, that's equivalent to the area in that interval as a fraction of the total area of 1. In this case, the interval represents 30% of the total area, or the probability of being between 12 and 15 ounces is 30%, or 0.3. We will use this concept of area under the curve as we consider other probability distributions